Hello guys, welcome to my YouTube channel. So today we are going to discuss one of the most important problems which came in GATE 2022, and this problem is also one of the most common problems in bioprocess engineering. So basically this problem is on fed batch operation. Okay, this problem is on fed batch operation. So if you know the fed batch operation, you can understand it easily. If you don't know or if you don't understand, I encourage you to go and watch my lecture on all the processes: batch process, fed batch process, continuous processes, so that you will get an idea how to solve these kinds of problem. So I will read the question first. The amount of biomass in a reactor at the end of the batch process is 50 grams. So what did they do? They have told you that they have conducted a batch process in a batch reactor, and the amount of biomass that is left after the conclusion of the batch process is 50 grams. Okay. Now what they are doing is they are conducting a fed batch operation on what the leftover biomass is there after batch operation. So they are using this leftover biomass of the batch process in a fed batch operation. They have clearly stated that they are doing fed batch operation is initiated by feeding the substrate concentration at a constant rate of 1 liter per hour. So they have told you the substrate concentration also. The concentration of substrate in the feed is 50 grams per liter. So they have told you the concentration of the substrate. They have told you the feed flow rate of the substrate. So this 1 liter per hour is actually the feed flow rate of the substrate, and this 50 grams per liter, this is actually the concentration of the substrate. Okay, so both are different. So feed flow rate means the rate at which you are giving a particular thing. So in this case, the rate at which you are giving the substrate is 1 liter per hour, and the concentration that you are giving is 50 grams per liter. Okay, and they have also told you the maximum biomass yield is 0.4 grams of biomass per gram of substrate. They have also told you, assuming the system is at quasi steady state. So this is very important. You have to assume that everything is in quasi steady state. Then you have to tell what is the maximum amount of biomass after 5 hours of the feeding. So this problem is very simple problem, but one thing people confuse: in the first line they have said that the amount of biomass in the reactor at the end of the batch process. So people come and see that it is written batch process, they apply batch formula, but read the question carefully. They have said that this biomass that is generated in the batch process will be used in the fed batch operation. That is the thing. So this biomass 50 grams is actually the initial biomass that you are feeding in the fed batch operation, and you are asked to calculate the final biomass. Okay, so you have an initial biomass, you are asked to calculate the final biomass. You have been given the biomass yield, maximum biomass yield. You have been given the substrate concentration in the feed as well as the feed flow rate. Okay, so these 3 or 4 things you have been given. So for fed batch operation, our formula is x is equal to x naught plus f of y xs s naught into t, where x is what is the maximum biomass produced after 5 hours. X naught is the initial biomass which is given to be 50 grams. So this x 50 gram is actually the initial biomass that you are giving for fed batch operation. F is the feed flow rate, which in this case is 1 liter per hour. Okay, and the substrate concentration, which is 50 grams per liter, and y-axis is actually the maximum biomass yield, which has been given to be as 0.4 grams of biomass per gram of substrate, and time is in 5 hours. So you have to find x. So everything has been given here. So what is the unit of x naught? It is in grams. Okay, and you have to find the final x in grams also. So this total thing should give you a final unit of grams. So let's see if we can get. So what is the unit of feed flow rate? It is liter per hour. Okay, feed flow rate is liter per hour multiplied by what is the unit of y-axis m, it is gram per gram, so it basically cancels. And what is the unit of S naught, substrate concentration, it is grams per liter. And what is the unit of time, it is hour. So this grams get cancelled, this hour get cancelled, and this liter get cancelled. So final unit is grams. So this is also suitable, right? This is also in conjugation with the other units. So you can only add quantities of same unit. So you can add x naught with f y-axis s naught into t. So you have been given everything, you just substitute the value and you get the value of x, which is the final or the maximum amount of biomass after 5 hours is 150 grams.